Hello, this is Mr. Klein, here to show you how to use this moon phases activity sheet to find out what it is that causes moon phases. The answer may surprise you. Okay, we've got on this page a list of things to diagram, and then we have the question to answer at the bottom. What's the only thing that changes with each moon phase? When you start off with this, some students may think, well, the amount of sunlight that hits the moon changes, and that's why we see the full moon or the crescents or the quarters or the gibbouses. But we're going to see what actually changes here. And we're going to start off by labeling the rotation direction of both the Earth and the moon. So I've got a little green arrow here, and I'm just going to label that rotation, and I'll do a little arrow here, rotation. So the moon and the Earth are both rotating counterclockwise. Next thing we're going to label, we can cross that off, is the ecliptic plane. This is important, especially because when you teach moon phases, you generally follow with eclipses and then seasons, and the ecliptic plane is an important concept to introduce now. And so I've got a ruler here, and I'm just going to do a red dotted line there you go, across. Hopefully I can get more or less the equator. That's pretty close. And then through this moon right there. Okay, ecliptic plane. Next, the terminator of Earth. It's kind of a fun idea. We've got the line that separates light from dark on the Earth and on any planet, any moon. They all have a terminator because, being spheres, half of them at any given time will be illuminated and half of them won't be. Now, Earth terminator, as I said, separates day from night, but it's also very important to know that moons have terminators too. Or our moon has a terminator. And guess what? That terminator is not going to change here relative to the sun, but of course its position does change relative to the Earth. And this is our first clue of what gives us moon phases here. So it's important. One of the first things that we usually teach students is half of the moon is always illuminated, half of the moon is always in shadow, and so it's not the amount of sunlight that the moon gets that causes the moon phases. And drawing the terminator here just helps illustrate that. All right. So that's the terminators of, well, the terminator for each moon phase here. 5 and 6, I've put them together. The visible half of the moon and the lines of sight from Earth. So we've got an important pattern here. Half of the moon is always illuminated, and half of the moon is always visible from Earth. And when I do this with students, as you can see, I usually use 3 or 4 different colors. I buy them cheap kind of 4-color pens, and we do that with, we use them for ratios or fraction division, also helpful for things like this in science. But so we're going to do the visible half of the moon. So when we draw these lines, let's start that over. So we draw the visible half of the moon, And it's important to realize that, yeah, we always only see half of the moon from Earth. And for example, when we have these lines of sight, in a new moon, the terminator lines up exactly with, you could say, this half line representing what part of the moon that we can see. We can see one half of it, but in a new moon, well, the half of the moon that's illuminated by the sun is on the other side of what we can actually see. So we're going to label that new moon. And the moon's terminator lines up with the half of the moon that's visible, or would be visible from Earth. And we're going to draw these lines of sight for a first quarter moon. And at this point, as we do these, the lines that mark half of the visible moon, or the half of the moon that's visible from Earth, this is where students tend to start having their aha moments. Oh, I can see that. Let's see, the half of the moon that's visible from Earth, most of it is in shadow in a waxing crescent. And so only that little pizza slice there, that small, it's a crescent. That's the only part of the moon that is visible from Earth when the moon is in that position of its orbit. And it makes even more sense when we go here to, this is a first quarter. Why do we call it a quarter? It's very clear when you say that, okay, half of the moon is illuminated, half is dark, and then of the half that we can see, only you can see 1/4 of the total moon there. That's visible, and that's why we call it the first quarter. So we keep on drawing these lines of sight. Waxing gibbous. Will that name ever change? It seems like a strange name, hunchbacked or humpbacked. I don't know. Seems like there's so many better names than gibbous. But here we see that a smaller sliver of the moon is not visible, and most of the moon, of the illuminated half of the moon, most of it is visible in a waxing gibbous. Only a small little sliver is not, of the illuminated part is not visible. Then down here, we got the full moon. Why is it a full moon? Because the full portion of the illuminated half of the moon is visible from Earth. Full moon. And then on this side, we've got waning gibbous. And why? Because, again, most of the illuminated half of the moon is visible from Earth. And third or last quarter, again, because 1/4 of the total moon is visible from Earth during that phase. And we've got waning crescent. Oops, there we go. Because only a small sliver of the illuminated half of the moon is visible from the Earth. And if you want to have the kids try to do that explanation when they draw the phases, very helpful for them to put what they're representing into words, of course. It's not easy, as you can tell by my trying to explain it here. Okay, so we've done the visible half of the moon and lines of sight from Earth. We have done the moon phase names. Now, SEM angle of each phase. That is the Sun, Earth, Moon angle represented in each phase. I think I'm going to go for a nice purple on this one. And this is the key concept here. What changes as the moon orbits the Earth is this angle between the Sun, the Earth, and the moon. And so I try to represent that here by drawing little angle lines, you could say, within the Earth. And if we start, you don't want to start all the way from the Sun, because that usually leads to a lot of messy lines, but we could kind of do kind of little dotted line there. The angle, and you know, do this with the students to show that, okay, the angle from the plane of the ecliptic to the Earth and then straight back, well, that's a 0 degree angle. So you could say the new moon has a 0 degree angle. But again, if you start from the Sun across the ecliptic plane, go to the center of the Earth, and then head up towards waxing crescent. And if you have a protractors for all the students, you can sometimes lie them on top of this here, and they can see the angles. A lot of times kids will, you know, if they know 45, 90, 135, you just have to know the 45 degree angle increments, and they're fine with this. They know that this angle right there is about a 45 degree angle. So maybe we can even put that right there, 45 degree angle. Coming from, again, the Sun to the center of the Earth and then straight up here, that is a 90 degree angle to the first quarter. And then Sun, Earth, and Moon with the waxing gibbous is a 135 degree angle. And from the Sun to the Earth, straight across that plane of ecliptic, 180 degree angle. This is information overload. You can always skip this with your students. But the concept of angles and how angles help create moon phases, eclipses, and seasons, it's a pretty important unifying principle, that pattern, one of those cross-cutting concepts that we talk about in NGSS. So 180 plus 45, 225. 270 to the third quarter. And then again, Sun, Earth, Moon, waning crescent has got a 315 degree angle. And back up from the Sun, Earth to the new moon, 0 degrees. We've gone a full 360 degrees. There you go. So we've got the angles of each moon phase. And we're going to do approximate time of visibility now, just to show how in Earth's rotation, the different moon phases will be visible at different times of the day. And if you see a faint shadow of a moon during the daytime, well, it's going to be one of these 4 that are on the visible side, the light side of the Sun, Earth, Moon system. So new moon, yeah, it's usually dark, although some Earth shine can bounce back and give just a faint illumination of a new moon. And then waxing crescent, first quarter, and then back down to the third quarter, waning crescent. I like to just use very approximate times here, and I think we'll go with the red color on that. Of course, these depend on what season you're in, what your latitude is. But a new moon is going to be roughly visible from 6 a.m. to 6 p.m. And then we move up to a waxing crescent. That's visible from, again, roughly 9 a.m. to 9 p.m. We'll give each day about a 12-hour cycle. And what your students may realize at this point, hey, wait a minute, we're just going up by 3 hours every time, 3 p.m. Here 12 p.m. to 12 a.m. And why are we increasing 3 hours or delaying 3 hours on our time window there every time? Well, if your students count up, they may realize 1, 2, 3, 4, 5, 6, 7, 8. We have 8 moon phases. And so in a 24-hour cycle, one rotation of the Earth, well, you divide 24 by 8, and you get 3 hours. So an approximate 3-hour delay as we move around Earth's rotation. 3 p.m. to 3 a.m. waxing gibbous. And then, of course, the full moons, they happen at nighttime, so nighttime is usually within that 6 p.m. to 6 a.m. range. Waning gibbous, 9 p.m. to 9 a.m. So it is possible to see a waning gibbous there early in the morning. There we go. And the third quarter is, adding 3 hours to that, 12 a.m. to 12 p.m. And at this point, or before, your students may start noticing, hey, wait a minute, the new moon phase, if it starts at 6 a.m. and ends at 6 p.m., well, directly across from that, the full moon phase is going to start around 6 p.m. and end at 6 a.m. Same with the first quarter. If it starts at 12 p.m. and ends at 12 a.m., the third quarter is just going to be a reverse of that, 12 a.m. to 12 p.m. And so waning crescent, we could either add 3 hours to the 12 a.m. of the third quarter, or look up at waxing gibbous and say, okay, if waxing gibbous directly across starts at 3 p.m., then we're going to start the waning crescent at 3 a.m. and end at about 3 p.m. All right. So there we go. Approximate times of visibility. Wow, this is looking nice and colorful, isn't it? Very busy. The last one, crescent and gibbous and night and day quadrants. Well, we'll just make this one very simple. And let's see, it helps as part of just the recognition of patterns here. If your students can see, well, let's see, when is the moon waxing? The moon is waxing, and you can just draw a little, maybe in black here, a little quadrant wherever they have room, and they can say, all right, I know that the moon is waxing. If the sun is, on the right side of our diagram, it's going to be waxing when the moon phases have just come out from the new moon, and they're going to be waning in this lower half, and the half that is, you could say, behind the Earth, if the moon is on the far side from the sun of Earth, then those are going to be the gibbous phases, waxing and waning gibbous. And if the moon is on the sun side of Earth, then those are going to be crescents. There. Just seeing those patterns, recognizing those patterns. And that helps if you give your kid a diagram that's a very clean diagram with just the sun and the earth and then a moon at a different part of the phase, whatever it is. And they might remember that if they draw a little diagram or remember the diagram, oh, okay, that's on the sun side of Earth, so that's got to be a crescent. And if it's on the far side of the Earth, then it's got to be a gibbous phase. Okay, now the fun part. We need to explain, put into words what this diagram has taught us. We'll go back to green here and answer this question. What is the only thing that changes with each moon phase? And again, this is where you want your students to recognize that it's not the amount of sunlight that the moon receives. It's not that we see more or less of the moon. One half of the moon is always presented to us, and one half of the moon is always illuminated. But the relationship between the illuminated half and the visible half, that's what changes. And what is it that makes that change? We'll say the angle. And some kids want to say the angle of the moon. If you just have one point, obviously you don't have an angle, so it needs to be, you need 3 points for a moon. So we'll say the angle. There's not a ton of room to write, but that's okay because we're going to keep this simple. Between the sun, we can just abbreviate here, sun, earth, moon, changes as the moon orbits Earth. I'm going to abbreviate moon there. What is it that gives us the moon phases? Changing angles. So angles are what change. And they change as the moon orbits Earth.